Hi friends, this is Sri Ramulu. So today's topic is energy density. What is energy density? Energy density. Before knowing this energy density means energy per unit length is called energy density. Which energy? Total energy. Total energy means kinetic energy and potential energy. Okay friends, energy density means energy per unit length here. Okay, here is unit length only. Why we are not taking unit per unit area per unit volume? Why? Because it is a string, no need to take area and volume, only we have to take here length only. Okay, let us consider a transverse wave is moving in a string along positive x direction. Due to the wave motion, the particles of a string vibrate about their equilibrium position, and the particles pass the disturbance to their neighbors without any translatory motion. Here, due to the wave motion, what is particle doing? Particles of string vibrates about their mean position only. So they vibrate like this only particles, and the particle pass the disturbance. Just they are passing the disturbance to the neighbors, to the neighboring particles without translatory motion, means without moving this particle this side. Just particle is vibrating there only, it cannot move away from this vicinity, this position. It here only, but it sends a disturbance to the neighboring particle. The vibrating string possesses both kinetic energy and potential energy. Now the kinetic energy. Consider a small element of length dx in the string with a linear density mu as shown in figure. Figure is given. As the length of the element is small, assume that there will be no change in its tension at both ends. So when it is small, tension is a constant mostly, almost. Let the mass of element is mu dx. Yes, in the previous video also I explained why it has come as mu dx. Mu dx is, mu is a linear density, can be defined as mass by length. So this length is taken as dx. Bring this side. Mu dx is equals to what? Simply m. So kinetic energy formula is what? Kinetic energy is half mv square. Okay, your transfer velocity is what? Dou y by dou x. Yu is a function of distance and time. Dou y by dou x dou t. Then kinetic energy of the element is this one. General formula is half mv square. In the place of m, mu dx. In the place of v, velocity is what? Velocity is dou y by dou t. But square is here, square is there, so that is the square is written. Okay friends, how does it has come? But it is very small, that is why instead of taking k as dk, dk indicates small kinetic energy. And see the diagram here, this is the diagram. Okay, so it is a small portion is taken, and along x direction its length is dx, along y direction its length is dy. Next, potential energy. So like this, it is a kinetic energy. Kinetic energy equal equation 1. Okay, and here uh, kinetic energy per unit length. So bring this dx this side, it is a kinetic energy by length. So kinetic energy per unit length, what we call kinetic energy density, mu by 2 dou by dou y by dou x dou y by dou t whole square. Okay friends, so dx is brought this side, so that becomes dk by dx, and remaining this there. So it is equation 1. And next equation, next potential energy. When the string is stretched, the length of the small element becomes ds from dx. So what is the length ds from dx? So it is a beginning, let its a distance is dx. Now what I am doing, this string I am stretching it, let its length has increased, then increased length, let me take it as ds. It is increased length, it is initial length, so which is greater? ds must be greater than the dx. Okay, once again, let it is a string which is fixed between the two ends with a length dx. Now what I am doing, I am extending both ends. Then what happens, let because of extensional force, let it is extended like this. So extended length, let me take it as ds, extended length from here to here, but actual length is dx, extended length is ds. Okay, so it is a greater length, it is smaller length. So that is why here ds minus dx is written. Why, why it is written higher length minus lower length. Next, therefore the change in length of the small element is given by, so extended length minus previous length, that is gives change in length, assuming that tension of string constant even if it is stretched. So at the beginning how much tension it has, after extension also its tension is constant. Why? Smaller length is considered. The work done to deform the string is equal to the potential energy stored in it, right? So potential energy, how does stored? So when it is extended, after extension, if you release it, it is it gains its original position and shape. Original position and shape is called deformation. So after deformation, it has stored the energy in the form of potential energy only. So that is why potential energy is equals to potential energy generally denoted by U, but small length, because of small length, small potential energy present, so that is what du. Du is equals to tension into change in length. It is a formula. Why change in length? Potential generally work done is equals to force into distance. Distance here, change in length is also gives to us distance. And this is a force. Force is nothing but tensional force here. And work is what? Potential energy. Okay, from the figure. See figure, ds is equals to under root. Why it is ds is equals to under root? See the diagram. This is the diagram. So let this length is as ds. This length is dx already given. This length is dy. Okay, already see in the diagram. It is ds. But according, see it is a one right angle triangle. According to Pythagoras, what is hypotenuse square is equals to side square plus side square. So what? Hypotenuse square is equals to side square plus side square. This side is dx and this side is dx. Okay, and keep a ds only here, and bring the root this square that side. So then what happens? ds is equals to under root dx square plus dy square. Okay, so same figure has come. ds is equals to under root dot dx square plus dy square. See here, is it now clear? Okay, and we can write this is a root as like this also. Next, so now what we have to do, bring dx square outside. Okay, so for the dx square, root also comes. Okay, how see here, ds is equals to what it is, dx square. So dx square I am taking outside. Okay, for this also 1 by 2 comes. Why? Because it is a 1 by 2 is common to dx square and dy square, and inside 1 plus here dy square by dx square present. Why? Dx square is taken outside, so for square root cancel, so only outside dx will present. Okay, so it is common square, both square are we have, so that is a common square. Now see, it is in the form of 1 plus x power n form. According to binomial, we can write 1 plus nx. Whatever power you have, simply write it in the multiplication. See, so power already 1 by 2 were there. This 1 by 2 has written here 1 by 2. This 1 by 2 written in this side only, nx form. Okay, so I applied. This n is just to multiply it here. So this 1 by 2 is just to multiply it here. Now multiply inside dx. So this 1 dx into 1 dx only, dx into this one dx only. Okay, now bring dx outside. It now positive. Bring this side negative. So I got change in length as ds minus dx is equals to 1 by 2 dy by dy by dx whole square into dx. Okay. Now we get du is equals to, so I'm substituting this in the equation 2. What is the equation 2? See, this equation is of force t into ds minus dx. So already ds minus dx we got how much? See, this is we got. So this is here, it is replaced by with this is replaced by this one. Okay, now bring dx, so this is the potential energy. Now bring the dx this side, it gives a potential energy per unit length. Okay, like this. So therefore the energy density is given as density is, energy density is equals to kinetic energy kinetic energy per unit length. Actually here we have to write per unit length plus potential energy per unit length. So sorry for this, per I have forgotten, make it correction. Energy density is equals to mu by 2. So it is a kinetic energy and it is a potential energy formula. Let is equation 3. Now for this, so I am going to calculate the solution. Let us consider the wave solution given by, so y is equals to a sine of omega t minus kx. So what we have to do is y. So one time we have to differentiate with t and next time we have to with the x only. So first let me differentiate with the t. So then what we get, if we differentiate with t, what? Dou y by dou t. Okay. So sine become cos and t multiplication omega, so omega come outside. So this next again fourth equation again, that differentiated with respect to x. Okay, so sine become a as it is only, sine become cos. Okay, but x we are differentiating with x, so then x coefficient what we have, minus k, so taken outside minus k, and substitute these two values in the above equation. What is the above equation? This is above equation. So here it is substituted and here substituted. Okay, this is substituted here, it is substituted here with a negative. For square, negative becomes positive, so forget it, positive negative, y square is there. Now what we can write here now, but average value here, cos omega t whole square is there, average value, it is, we have to take it as average value as 1 by 2 in the place of here and here 1 by 2 substituted, 1 by 2 1 by 2. Okay, now let it is equation 5. Keep it like this only, and we know the k is equals to omega by v. Okay, so energy density in the place of k, here you have the k, omega by v substituted and whole square, k square we have whole square, and it is separated like this, omega square by v square. Okay, and this v take this side under t, what, then t by v square it is. So t by v square, from this formula t by v square can be written as mu. So in the place of this mu, omega square by 4, omega square by 4, a square. Now see, these two factors are same, so that is why we have to add them. So it becomes 2 into this one. So 2 ones are 2 2s are here 2. So this is our formula. Or if you substitute omega value in the place of omega, then we get this formula. Omega is what, 2 pi f. So already omega square is 2 pi f whole square. So 2 becomes 4 and 2 becomes 4. So here 4 is written, pi square f square, 2 ones are 2 2s are. So this is the formula. So okay friends, so this is our video. So don't forget watching this video till the end, and please encourage me for subscribing this video.